Welcome, everyone. I am super thrilled to have you here for this explainer. Today, we're taking a really fantastic practical guide from Mobisoft Infotech and transforming it into a structured, step-by-step technical breakdown. We are going to explore exactly how to implement secure biometric authentication, specifically fingerprint and Face ID login, natively within your Flutter applications. If you're a developer, a technical architect, or a product manager looking to level up your app's security and user experience without getting tangled up in messy workarounds, well, you are in the exact right place.
Okay, let's take a quick look at our roadmap. We're going to cover the core authentication problem, get a high-level Flutter overview, configure our native platforms, build out the actual authentication workflow, design the user interface, and finally, wrap up with some critical security takeaways. Let's dive right in. Part 1. The authentication problem, and of course, the solution. Let's be honest for a second. Why are we still relying on passwords when we can use a user's unique biological characteristics? Passwords have some pretty inherent flaws, right? They get forgotten, they get guessed, or worse, they get stolen in massive data breaches. Biometrics, on the other hand, things like fingerprints and facial recognition, they verify a user's true identity seamlessly. You're no longer verifying what a user knows. You are verifying who the user actually is. The source material lays out some massive benefits here. First up, we get significantly enhanced security, because biometric data is unique to each individual. It can't just be copied and pasted like a text string. Second, it offers a vastly superior user experience. Your users get quick, frictionless access to their accounts with literally just a glance or a touch. Third, and this is a big one for developers, it drastically reduces the risk of password-related security breaches. Why? Simply because users don't need to store or remember complex passwords anymore. And finally, implementing this basically ensures your application is complying with modern market security standards, keeping you competitive and trustworthy. Moving right along to part 2, our Flutter implementation overview. So, now that we understand the why, let's talk about the how. How does Flutter support this natively so we don't lose our minds writing completely separate code bases for iOS and Android? Well, the absolute foundational tool for this entire workflow is the Local Auth package. This is an official Flutter plugin that provides a really clean, unified API for authenticating users across both major platforms. It essentially bridges the gap between your dark code and the device's native hardware, whether we're talking about a fingerprint scanner or a Face ID camera array. Getting this setup is super straightforward. If you're familiar with Flutter at all, these are just your standard prerequisites. First, you set up your project using the Flutter CLI. Second, you open up your pubspec.yaml file and drop in that local auth dependency. And third, you just run your installation command to fetch the package. You have to have these basics in place before we can start writing any custom authentication logic. All right, part 3, platform configuration. This is where things get a bit more specific. Before we can write a single line of Flutter UI code, we absolutely must configure our native operating system permissions. On the Android side, we need to head over to the Android manifest.xml file. There, we add use biometric for modern authentication methods and use fingerprint for backward compatibility with older devices. You also want to use a feature tag to indicate that this hardware is optional. That way, your app doesn't just crash on devices that don't have scanners. Now, over on the iOS side, it's all about user transparency. In your info.plist file, you have to add the NS Face ID usage description key. The text you put here is actually shown directly to the user via a system prompt, explaining exactly why your app needs access to their face. Next up, part 4, the authentication workflow. With those platform permissions securely out of the way, the absolute most effective way to build the core logic layer, as highly recommended in the Mobisoft guide, is to encapsulate all this functionality into a single biometric helper class. Think of it as the brains of the operation, using a strict 4-step flow. Step 1. Is device capable? This simply checks if the physical device even has hardware support for biometrics. Step 2. Is biometric enabled? Now this is different. A device might have a scanner, but the user may have never bothered setting it up. This step confirms they've actually configured biometrics in their OS settings. Step 3. Get biometric type. This tells us if we're dealing with Face ID or Touch ID, which is vital for our UI later. And finally, Step 4. Authenticate. Once everything is verified, this method actually triggers the native system prompt. Handling things in this exact order is a game changer. It entirely prevents your app from throwing nasty errors or showing useless buttons to the user. Part 5. User interface and experience. Let's wire that helper class into the presentation layer. By using the variables from our helper, we can create a highly dynamic user interface on a standard login page. First, we initialize our helper in the widget state. Then, and this is a really good best practice, we check the capability and enabled status right on page load, straight inside the init state method. Because we know the device status immediately, we can conditionally render the login button. If they don't have biometrics, the button simply doesn't appear. If they do, we use our underscore biometric type variable to accurately label the button, so it actually says login with Face ID or login with Touch ID. Finally, when they tap that button and trigger the Authenticate method, our UI seamlessly handles the true or false Boolean return for success or failure.
Quick testing tip here, and this is a big one, straight from the article. When you are developing this, you must test your biometric authentication on physical devices. Emulators and simulators often lack the proper hardware abstraction to trigger these specific biometric dialogues correctly. To make sure your success and failure states are actually doing what they're supposed to for your end users, you need to deploy to a real Android or iOS testing device.
And finally, Part 6, Security Considerations and Key Takeaways. To wrap up this architecture journey, let's reinforce exactly why this setup is so robust. First and foremost, this workflow completely eliminates password storage vulnerabilities for subsequent logins. It relies entirely on unique biological data that's verified securely by the OS itself. And because we built that helper class, it handles errors gracefully and provides immediate user feedback right in the UI. It absolutely guarantees explicit user consent through those unbypassable system prompts. Plus, this encapsulated modular architecture means you can easily extend your app later to include fallback authentication methods, like a traditional email and password if the biometric check fails. To close out this explainer, I want to leave you with a really powerful thought from the Mobisoft Infotech Guide. By implementing biometric authentication, you're not just adding a feature, you're investing in your application's security and user satisfaction. When you utilize the local auth package and structure your code thoughtfully, you build a professional, incredibly secure gateway to your application. So ask yourself, how many users are abandoning your app right now just because they are trapped in a frustrating password reset loop? It might be time to upgrade your authentication. Thanks so much for joining me today, and happy coding!